Hello. Each chapter in our book has a review section to help you prepare for the test. In the review, the author has brought in concepts from the chapter that are important to give you a chance to go through those before we take a test on them. I'm going in a little bit of a different order on our lesson today. I'm going to start with set 3. This is a nice project. We will probably work through this in class, but just in case, thought I would introduce it here. So the Roman poet Virgil, probably a story, probably not true, but it's a fun one and it introduces a fun geometry puzzle. A princess named Dido wanted to buy some land, but women couldn't do that back in those days. But since she was a princess, they said they had to make some accommodation. So they said she can buy as much land as she could enclose with the skin of an ox, and snickering behind her back. Sure, if you cut an ox and spread it out, it would cover some area, but not very much. But they used an unfortunate word. They weren't very careful. As much land as she could enclose with the skin of an ox. So she figured out a way to do that. She cut the hide into strips, tied them together, make a super long cord. So here's a picture of what it may have looked like. So she kind of outsmarted them. Question now that we want to ask is, how much land could she possibly get? Obviously it's going to depend on how thinly the strips were cut, but let's suppose that her plot of land had to be in the shape of a rectangle. It could face a river, so the cord would have to stretch only along 3 sides. She was able to get 900 yards of cord from that hide. So here would be one possibility. Going along a river is pretty smart. You get water, but also you don't need to waste any of your strips of hide to surround your land. So here you see we've got 300 plus 300 plus 300. That's the 900 yards of cord. Now, what would the perimeter of this property be? Now we include the river when you include the perimeter. So you're working through the perimeter, and then what is the area? So you're going to get a number there. Is that the best she can do? Is there a better configuration? What if it were to go this way? Well, so we've got 200, 200. Well, obviously you need to figure out what's the top here. Remember, she has 900 yards of cord. Perimeter, area. So maybe you can guess the puzzle here. What length and width should the rectangle have for Dido to get as much land as possible? Make some drawings to try to find out. Does this feel like inductive reasoning or deductive reasoning? Well, let's see what you can come up with. So here's the rest of chapter 1, the review. You'll see he walks you through some real life situations with pictures that reinforce some of the concepts and the vocab that were introduced. So here's a die, 700 BC, quite a while ago they were using dice already. The corners of the cubes, he's saying, are good representations of points. So an undefined term. Now he wants you to think about some other geometric figures vocab that we had. What would you call the edges? So he's talking about that. The faces, he would be talking about this. We're looking for vocab terms from this chapter. The cube itself, can you assign a name to that? Okay, how many edges meet at each corner? So you're picking a corner. How many edges would meet there? How many edges does the cube have altogether? And then 2 questions about the faces. 6 and 7 are about the faces. The corners A, G, and C are non-collinear. There is no one line that contains them all. But what is a word that would describe them? Yeah, non-collinear is what they are. But is there another word? Yes, there is. We talk about these quite a bit later in the year, but this is a net, short for network. It's a 2-dimensional figure that when assembled would create a polyhedron, or a three-dimensional figure. In this case, it could be used to form a cube, you see up here at the top. In how many lines do the edges of the pattern lie? In how many lines do the edges of the pattern? So edges would be, as we heard, all of these segments here. How many lines do you need for all of the edges? Remember now, this is an edge. Oh, I'm sorry, edge of the pattern. This is not an edge of the pattern, is it? This is, and this is. How many lines would you need? Suppose you cut it out and fold it. Now you've got a cube. Now you have to try to figure out which edge would each of the following edges come together. So JW, which edge would come together with JW? How are you at visualizing three-dimensionally? You could make a copy of this if you wanted to and create it, but it's up to you. So a few more questions. Which edges, which corners would they come together with? Here's a picture of that cube. But depending on how you look at it, if you look at it as flat rather than a three-dimensional cube, what polygons do you see? There's more than one. Make a copy of it, but make it look three-dimensional. Drawing it with the hidden edges as dashed line segments. Have you done that before? Make some of them dashed and see if you can make it look 3D. 17 is an interesting question. What is the greatest number of faces of a die that can be seen at any one time? Make a guess at it, but then try to find a cube and see if your guess is right. All right, again, more review of something we did in this chapter. Some drawings are made with a ruler and protractor, and others made with just a straight edge and a compass. So two different kinds of drawings. What do you call the ones in which you use just a straight edge and a compass? Here, they want a drawing made with your ruler and protractor. That looks like this. 70 degrees, 30 degrees, 3 inches. Do it in the center of a sheet of paper so you've got enough room for the rest of the steps. Measure all the angles in here. Now notice we've extended the sides. Measure the angles. So make sure you get the right angle. Angle DAB. A would have to be the vertex. DAB. ABE. B would be the vertex. DCE. DCE. Measure those angles. So there's practice measuring. Now use your straight edge and compass to bisect DAB and ABE and draw the bisectors. So they meet at a point called F. And then measure the angles. Since you're bisecting, you should have an idea what those measures should come out as. So it would look kind of like this. So bisecting angle DAB. Making sense? Okay. Then you're doing that on the other side. So practicing bisecting angles. And we label that F down there. And then draw CF in. So we're just following directions, sweating the details, measuring some more angles. 26. What does line CF seem to do to angle DCE? Quadrilateral shape. Straight edge and compass to bisect the four sides of the quadrilateral. M to label the midpoint of AB, so there'll be an M up here, so on. Now you would use the arcs to do the bisecting. I've just put in those midpoints. But on your paper, you should end up with the arcs. So I'd start here, I'd do an arc up here, and an arc up here, and then I'd go to B and do another arc and another arc. You can draw the whole line if you want, or you can just lay your ruler on there at the two intersections. Maybe it would be help if I do this. So at A, I would do an arc. Come on, there it goes. And at B, without changing my compass, I would do an arc. Whoa. Connect those two. Wow, that was a mess. But you got the idea. Lay the ruler on there, and wherever it intersects, mark that as the midpoint. So I've got the 4 midpoints in there. Connect M, N, O, and P. Connect those points. What do you notice about the sides of this quadrilateral? These sides, those sides. Notice anything about them? What's the perimeter in centimeters? Draw AC and BD. We're drawing those two. Got them in a different color. Diagonals. There's a new term. We'll use that quite a bit this year. Diagonals. Measure them in centimeters and add their lengths together. If you've drawn and measured everything accurate, your answers to 29 and 30 should be the same, even though your original copy may not look like the one above. So in other words, the sum of the diagonals, AC and BD, should be the same as the perimeter of this polygon you created. And they're suggesting that that works with any quadrilateral. Kind of makes you wonder. You could do that with GSP, and then you could drag it around and see if that holds true. All right then, this was to try to help you get ready for the upcoming test. If you have any questions on anything you've seen here, please find me and